The system comprises 2 pumps with dedicated automation that ensures the pumps are activated alternately based on the water level in the reservoir. The reservoir contains level sensors providing information to the PLC about the minimum, maximum, and average water levels. When the water level in the reservoir equals the average level, pump 1 starts and operates until the water level reaches the minimum. If the water level continues to rise beyond the average and reaches the maximum value, pump 2 is activated, and both pumps operate until the water level reaches the minimum. An alternation of pumps is necessary. With each new start, a different pump should initiate to extend the working life of the pumps. If the pump scheduled to start encounters an error, the second pump takes over until the issue is resolved. Now let's observe PLC in action as we program it. But first let's take a look how we designed and simulated water level sensors. First switch from the left side is the minimum water level sensor, second one is the average water level sensor, next one is the maximum water level sensor. Last 2 switches indicate that there has an error occurred on pump 1 or 2. If the switch is in the high position, pump is okay. If switch is in the low position, pump is not working correctly. Here is the functional block diagram we made and uploaded to the PLC in order to make this to work. Now let's observe what happens as water level rises. By hand, we will simulate water level sensors with opening and closing the switches. Okay, so water level starts to rise, setting the first switch on, that's the minimum water level. Nothing happens until water reaches the average water level. Green light that turned on simulates that the pump 1 is indeed working. Now water is being pushed out of the tank and pump 1 should stop working once the minimum water level switch is turned off. Now, next time water level reaches the average level, the other pump should do exactly what pump 1 did earlier. Okay, so the minimum water level, and then the average water level. Pump 2 is now working. Let's repeat the process, making the pump 1 turn on. But this time, suddenly water rises to its maximum water level. Now both pumps turn on to push out as much water as possible, reaching again the average water level sensor. Now let's say there has an error occurred on pump 1, which is equivalent to setting the error switch to low. Pump that is available should take the work instead. Great, the green light jumped from pump 1 to pump 2. We can also try this algorithm when the maximum water level is reached.